Welcome everyone. Today I'm going to be explaining how to use the HTTP client in an ASP.NET Core application, some cool things you can use, and about the IHttpClientFactory. So as you can see, the setup here is we got an API and a consumer. So an API is something that you can access. It's not going to be specifically a project that you have or set up yourself. It could be a third-party API, but I'm going to be using this API as an example of the things that you can do if you're, for example, going into something like a microservices architecture or something like that. But nevertheless, let's go ahead and get started, and we'll just start with the plain thing of what do you want to avoid, and primarily why does the HttpClientFactory exist and stuff like that. So both of these are very simple setups. They're essentially two APIs. It's just the consumer is going to be calling the API, and as you can see here, in the bad action, we are surfacing the HTTP client by just basically newing up an HTTP client. We're putting the configuration that we need, and we're just going to be calling the API in the background. Now I do have both of these running, so I have my Windows terminal here. On the left is my API, on the right is my consumer. So they're both running with .NET Watch Run. I might need to rerun them if I'm going to be adding packages and stuff like that. But essentially what this gives me is something like this. So every time I refresh this, I get an object that has name of home and a GUID. And this is because I am calling an endpoint on this controller, right? So all I'm doing is returning an object here, okay? And this is on the API side. So the reason I'm going to be putting some variables in here is to just explain the lifetimes of your HTTP client and where you can get values and where you shouldn't put values and stuff like that. So this is bad because the HTTP client has been notoriously bad for some time. I haven't been aware of this maybe a year ago. I wouldn't, if you'd asked me something about the HTTP client, I wouldn't know this, but as kind of a short overview of the problem, I don't want to delve in it too much because I want to show what to actually do. It's essentially when you do when you spin up an HTTP client like this, it will use up some DNS ports or some handlers on your actual hardware and won't basically free them up because HTTP client really has to communicate with your network drive and stuff like that. So there's a lot of basically the C and native bridges between this actual HTTP client and the actual thing that is going to be happening in the interface that is exposed in your card. So for this reason, it's basically there is the HttpMessageHandler and the HTTP client, and the documentation explained this quite well. I'm not too bothered about this as you just learn how to use the HttpClientFactory and you forget about basically spinning up your own versions of HTTP client, okay? Primarily, this is not a problem in older applications if you're not doing something like 1,000 requests a minute. Basically, if you're not doing too many requests, it's not a problem. Your machine might die after some time, or stop making requests. But the more requests per second you make, the faster you're gonna hit this wall of where your HTTP client is just gonna stop working. Okay, and that's basically the primary thing you want to be guarding against. So enough rambling on. This is a bad solution. Anywhere where you have to new HTTP client in an action in a repository, don't do it. So a simple use case of how to actually surface an HTTP client is on your consumer, you would go into startup, and as you can see, simple setup, just controllers and map default routes. What we do in our services is add an HTTP client, okay? And this is the simplest thing you can do. It's like a one-off thing. You just need an HTTP client somewhere. This is what you do. You add an HTTP client here. Let's copy the ban. Let's remove that hashtag. And we'll name this simple because it's a simple use case. And what we're going to do is we're going to accept from services. So this is just a dependency injection. You can do it in the constructor if you want. I'm just doing it in this specific method. And what you do is you surface an HTTP client factory. And now instead, what you do is you have the client and you grab the factory and you call create client, and this is going to create a client for you. So now you don't have access to this sort of to the setup as part of the newing up of the object. So all you have to do is just set the base address either on the GUID that you're calling, or just, you know, shift it. Just do what you need to do to set the base address. Any setup that you need to do here, putting access tokens on your authorization header, that stuff can be done. So let's put a semicolon here, save this, and let's go ahead and try to hit this simple and make sure we're still doing the same. We're still getting the same thing. So here I'm gonna go to simple. And yeah, the same thing still happens. I get a new GUID every time that we basically call this function, right? So one thing that you can do is, for example, this configuration here. You can see how we're essentially having to set the base address, and anywhere where if we basically have something like an interface that's hiding this HTTP client, we can have some base configuration. Here we don't have it, so this is what you generally do. In your startup, you would copy this, you would cut this, and you do your setup for your HTTP client here. So there are a couple of overloads. You can F12 to see them, and the primary one that we are after is the one with just the action with the HTTP client. You can have the one where you can have a nice service provider, so you can access your dependency injection container essentially through this iService provider in the builder function, right, where you configure the HTTP client. And you can also have these names which are named clients, and we'll dive into that in a second. So what you essentially do is you have your client here, and you have a function where you basically say the things that you want to do with this client. And sorry, I probably picked out the wrong function there, so we can actually, yeah, I think it's worth just going to the named ones. You can't have a configured client without a name. So yeah, let's just go ahead and call this simple. Okay, so this will be named simple, and all we're doing is we're basically having a client that we configured with a base address. Now, since we've done this, let's go ahead and try this out. Let's see if we actually just get our simple client through this bit here. So going back to the browser, let's go ahead and refresh this, and you can see that we provide an invalid URI. So what we actually need to do is we actually do need to supply the simple here. Okay, so now if we go back, refresh this, and we're back at a point where we basically see the response, and we're back to having an HTTP client, but at this point it's named. Okay, so the main point here is that you can have multiple clients with different configurations. It depends on what name you give them, and then you extract the actual client that you need through your factory. Okay, and just a quick note on the lifetimes. The factory itself is a singleton. Okay, so if you want a new client every time, do not like over every time you basically call it. If you want a new client, create client will give you a new client. Okay, factory itself is a singleton. Be careful if you're going to be creating a client in the constructor of a singleton, and basically be aware of the lifetimes. And one thing that we could have is for example, in the configuration here, we can have client, and we can have default request headers, and let's go ahead and add a startup header. Okay, and in the startup header, we're just gonna surface a GUID. We're gonna get a new GUID. We're gonna string it, so we can put it as the value here. And all we're gonna do is we're gonna go to the API controller, and this is primarily how we're gonna check how our client behaves. Okay, and we're gonna try to return the startup header here. So let's go ahead and basically put the startup header on here. And the way we would do this is we would grab the request headers, and we would try get value, or maybe not even that. Let's just go ahead, because we know it's going to be there, we can go ahead and grab it from the headers straight away. Okay, so at this point, let's go ahead and refresh this, and here you can see the startup header. It's an array currently, because you can because basically the header, the value that we get from here isn't really a string, it's a kind of string value. But besides that, the point here is that you get a new ID every single time for this and the startup header. So the primary thing to know here is that this configuration in your startup runs every time that you call create client. Okay, so for example, if you have a singleton service, do not call create client in the constructor, register the factory in the constructor, and then in the function that you're going to be executing, create a client there. So then you're going to have a fresh instance of the client every single time, because the singleton is going to be created once. Okay, so that's just an example of where you might run into like some unexpected problems. All right, so that's pretty much the named client. We can also do something along the lines of try to create a different client. So for example, if we want to add another client, we would go into services and again add an HTTP client. We cannot do this on this client, so you can see we cannot add another HTTP client because what this returns is an IHTTP client builder. So here when you register the client, you are basically adding stuff onto the client, okay? If you want another client, you go and specify add HTTP client, and then you basically give it another name, and based on which client you want to surface, you do that. So moving on, kind of the things that you would expect you want to do is you want to be able to have your own HTTP client, or maybe an adapter on the HTTP client. So essentially you're gonna have something with predefined routes and you're gonna put the HTTP client in it. So let's go ahead and see how that can work. So let's go ahead and create the client folder here, where I'm gonna be basically putting my custom HTTP client, right? So custom HTTP client.cs, and this is part of the typed client of what the HTTP factory provides. And yeah, basically what it allows you to do is have kind of like a constructor into which you are going to inject a HTTP client, okay? And we'll see how this works in just a second. So let's go ahead and inject the client, and for here I will just go ahead and I will basically offset the string that we're getting here. So I no longer need to create the client because that's what that constructor is going to do for me. I'm just going to go ahead and grab this bit and what's called task string. That's what we need to return. Get home, and let's go ahead and return this. Simple offset. All we have to do now is just register this custom HTTP client, and we can inject that straight away. So let's go ahead and see what we can do. We can grab the type, we can go into startup, and in services, we can go ahead and say add HTTP client. Here we supply the type, and we can go ahead and call it custom if in case we want to grab an HTTP client version of it with the same configuration, but not this type. If you don't want that, you can go ahead and omit that. So let's go ahead, we'll keep custom, but it is unlikely, if you specify your own type, it is unlikely that you want a name on it, because then you can just inject the type by itself. So here we can have the client, and the same thing can happen here. So, but here what you get a split of the setup for the client, because the constructor is gonna get called every single time. So the way we can check this is we can have our GUID, and we can create this GUID here, and we can toString it here. Let's go ahead and generate this field. Okay, and instead we'll just pass a GUID here. Okay, so treat this as base configuration. So wherever you're going to be surfacing this client in this particular consumer, or in a second particular consumer, this configuration should never change. Okay, this is something that's always going to be staying the same if it's some particular header or whatever, you know. And probably the answer to that one is you don't know, but essentially treat this as base configuration. This configuration will never change, or should never change, okay? Then you go into the startup. Yep, any configuration that you need there, you go ahead and you put it here. We're gonna observe the change of the startup header, so we can actually let's just go ahead and put it in our custom HTTP controller as well, just here. So let's say that this is base configuration, and then depends on what type of a consumer it is and where it's going to be pointing. This can be configured in the startup. Okay, so let's go ahead and spin up a controller action for this. So I'm going to go ahead and say that it's a typed client. And what I'm going to do is I'm going to get a custom HTTP client. I'm just going to call it client. And now I don't need this. And I'm just going to be using my get home function, okay? And it's just going to be the same thing as these two, but now I've pushed the configuration from where we surface the client, right, into either the startup, or if it's the really base configuration that all versions of these clients should have, into the constructor. Okay, so there are different levels at which you can configure it. Okay, but nevertheless, here's what we have. Let's go ahead and try this. So make sure simple still works, everything compiles. And let's go ahead, check the typed client. Okay, and if we refresh here, the main thing to note is that the ID for the home still changes, so the constructor is getting called every single time, and as well as the configuration in the startup from what we've just seen with the simple one is going to be changing every single time. Okay, so if you are going to be surfacing some services in the actual setup, make sure to understand that it's going to be doing it every single time. It's not a one-time setup. Okay, yeah, you get new objects every single time. Let's go ahead and talk about middleware. Okay, this is a recent problem that I have stumbled upon, and it took me a little bit of time to figure it out, but nevertheless. So how do you add middleware? First of all, you need a delegate handler object. Okay, so here we're just gonna say that this is some kind of HTTP context middleware. Okay, the reason I'm calling it HTTP context is because I want to demonstrate the lifetime of the middleware and primarily some things that you want to avoid doing with the middleware. So HTTP context will stand for that I'm going to be injecting the IHttp context accessor into it and trying to access some things. Okay, so let's inherit from a delegate handler, I believe it is, or maybe delegating. Yeah, so delegating handler is the object that you want. You can then press Alt Enter on the end, basically on the body, and you can generate overrides. And the primary thing that you want to override is the send async function, right? So let's go ahead and deselect all other ones, and we will grab the send async function. Okay, let's format this a little bit. And if you want to know more about middleware in general, I have a middleware video. I'll give a link in the description and the annotation above. So the primary thing here you can do is you can do stuff like attaching your authentication tokens. You can do stuff like catching 401s or 403s and trying to refresh your tokens and stuff like that if you're doing that sort of thing. Here I'm just going to be doing a mock of basically trying to inject your HTTP context and then seeing some errors that could occur. But first of all, let's go ahead and just get our heads around the lifetimes of this middleware. Okay, so let's go ahead and put a constructor here, and what we're gonna do is we're gonna add a middleware CTR. So this is gonna be CTOR constructor. Let's just call this CTOR value. So we'll grab a GUID, new GUID, and we're gonna toString this. Let's go ahead and create a field, and we're gonna have the same thing, but this is going to be a method. Okay, and forgetting my vowels a little bit, but all we're going to do is on the request here, we're gonna add headers the same way that we did in the setup. We're just gonna do it through here. So we're just gonna say middleware -CTOR, and we're gonna add the constructor value. Okay, and then we're gonna do the same but with the method. Okay, and we're gonna add the method value. And here all we want to do is we just want to know what changes where, so we understand what to put where. Okay, let's go ahead and grab the HTTP context middleware. We're gonna go into startup, and first of all what we have to do is we're gonna have to add transient this specific middleware, and then what we will have to do is let's actually put it on our custom HTTP client, because that's primarily what I'm expecting it to work with. Okay, probably we could put it on both. So let's go ahead and add HttpMessageHandler, and this is how you register your middleware. So basically it's going top from bottom, so the top one executes first, the bottom one executes last, or the bottom one is closest to the actual call going out and coming back. Okay, So, and let's go ahead and actually put this on both of them. So in case we want to check other endpoints of how they behave with the other client, we can. And if there are any errors, we can sort them. So we have the HTTP context middleware registered and attached to a particular client. Okay, let's go ahead and see what this produces. And in order to see what it produces, we actually have to go into the home controller of the API and surface the headers that we have attached. I thought I misspelled middleware there, but never mind. Yeah, let's go ahead and close this, as it's getting a little bit confusing with the files all open all over the place. So let's go ahead and we'll just call this C2R method header, and this will be the method header. Let's go ahead, copy one name, Control Tab to go to the previous one, Control Tab to go back. Okay, Control Tab to go back. Okay. And there we go. So I've added everything to the API endpoint. So let's go ahead and take a look at what headers, what values we're going to get, right? So going back to the HTTP client, let's go ahead and refresh this, maybe zoom in a little bit so it's easier to see. So if I refresh this a couple of times, you can see that the constructor header isn't changing, but the method header is. So it's not necessarily that the constructor header isn't going to get triggered again. It will trigger it again. We will see what exactly controls that. So because you remember we have indeed registered it as a transient, right? So we're expecting to get a fresh instance every time, but here we can see that the constructor isn't really being triggered again and again, and this will change in a bit, hopefully, from rambling. But let's go ahead and see what happens on the simple client. So if we go duplicate this and we'll call for a single. So if we refresh this, we can see it's 4E5. So constructor header still doesn't change. However, it's different to the typed client. Here it's quite simple, 4.3E, but still different. So if we refresh this, okay, it still hasn't changed, but essentially what we get is every time a message, HTTP message handler is created, that's when the middleware gets attached, sort of thing. So the lifetime of the middleware lasts for as long as the message handler basically lasts, and message handler is separate from the HTTP client. So HTTP client kind of sends stuff to the message handler. Okay, so if we go to the typed client, hopefully I think the default is set to like 2 minutes or something like that. Yep. So here you can see the constructor header has changed. This one still hasn't changed, but there is still a way that you can basically control how long a message handler gets cycled through, but you don't really, I don't think you really need to do that. I'm not actually sure of why you might want to do this, but just to sort of make a point for the set handler lifetime, you can go ahead and set it to maybe like 1 second. So let's go ahead and refresh this, go back to the type client, and if we keep refreshing it, you can see basically every second the value of the constructor header changes. So the key takeaway here is that the middleware is not applied to the HTTP client. The middleware is applied to the HTTP message handler. So doing stuff like injecting the HTTP context accessor and saving your HTTP context in the constructor can cause some problems. And let's actually take a look at what can happen. So if we go into services and we add HTTP context accessor, and we'll try to do something simple, and we don't even need to grab anything. We can just say context accessor. So let's say accessor, and if you do something along the lines of HTTP context in the middle, so accessor, we'll grab the HTTP context, create a field, and then maybe you want to do something along the lines of check if it is null. And we're not going to be doing anything, but primarily this is just to trigger an error. So going back to Google Chrome, if we refresh, the first time everything's fine. The second time, or a couple of times after, you will see that the iFeature collection has been disposed of. So essentially what we get here is if we refresh it fast enough, we're going to get this exception until a new instance of the middleware is triggered, so it can go ahead and grab that specific HTTP context. So what you need to do is you need to put this HTTP context into the method body, and then going back to the browser, you should no longer see this error occur. So looks like I have an error where the HTTP context doesn't exist. Okay, so I have to put in a variable. Accessor doesn't exist. Let's go ahead and generate a field for the accessor. Again, just forget to do a bunch of stuff. Okay, and now if we refresh, okay, so now it doesn't matter how often we refresh, because we are getting a fresh instance of the HTTP context from the accessor, and the accessor is a singleton. HTTP context is kind of resolved internally. Okay, so another thing I want to show is how you might want to abstract it, because let's say this API right here, okay, it's gonna have its own models. It's gonna inherit from some models, and it's gonna be returning JSON serialized versions of those models. What you want to do is be able to share that HTTP client in a microservices scenario. So you might have an API that 3 or 5 different types of services can call. They're all written in C#, and maybe you have a Blazor application or a Xamarin application that also might want to call this API. So you want to be able to share the HTTP client for this API. So I just want to show you what you could do. Let's go ahead and create a new project. We'll just call this a library. Next. And let's go ahead, call this entities. So what you do is you basically create your entities class, where let's say we will have a home.cs, or again we'll do something super simple. We'll just have a home, so we can go ahead and return this. So on the home controller, I'm gonna skip all this stuff. I will leave it here commented, but we will just return a new home. And we need to grab the dependency for this. So add a project reference, we add a reference to entity. We go ahead and using entities, let's say home equals our home. All right, and hopefully from here on you get the gist. We then go ahead and add another new project. This is a library again, and this is going to be the API client. Okay, so we go ahead and create this. Okay. And this will get a project reference to entities as well, because this is kind of what we want to return. So from here, we're no longer returning a, what's it called, an object, we're returning home. And from our client here, let's go ahead and delete this. And primarily what I want to do is just copy the custom HTTP client and HTTP context middleware into the API client. We will go ahead and rename this to API client namespace. And we'll do the same for the HTTP context middleware. Okay, so the primary thing that we're going to lose is references to ASP.NET Core specific things. So from the web framework, like the IHttp context accessor. So here is where we want to add some additional packages and make the registration process a little bit easier. Okay, so let's go ahead and first into the custom HTTP client. What we want to do is keep this the same, but what we're actually returning now is a home, and the get string async here. We go ahead and we say basically that it's a JSON object. And again, you can write some kind of middleware for this, but I'm going to show you an easier way that actually exists now. So let's go ahead and grab a JSON convert. We will need Newtonsoft for this. Or rather, no, never mind. I don't want to use Newtonsoft for this because there's an easier way that exists for this. So I'm just going to show you a package that you can use that recently came out, and it's using system.text.json. So the newer, faster JSON serialization just uses that. So what we're going to do is we're going to go to manage NuGet packages. And what I want you to search for is system.net HTTP JSON. I think that's the primary thing, but yeah, so this package system.net HTTP.json, go ahead and install this. We can then go ahead and add the namespace to here. So using system.net HTTP JSON. And what this will allow us to do is, instead of get string async, we can get from JSON async, okay? And here what we can do is we can specify a type that we want to convert it to. So this becomes, this basically takes away of all the complexity of putting all your, basically your custom JSON parsing and stuff like that. You can still take advantage of the filters that system.text.json provides, etc. All right, this is just a super simple way to just parse JSON. If you want to use some other format, I guess then this won't help you. But if you're using JSON, I think this should be your go-to now. This is a recent library that from this point was released like 13 days ago from preview. So it's no longer in preview. It should be available, and it's going to be included in a .NET 5. So going forward, I think this should be the preferred way, right? So we have this custom HTTP client, assuming dependency injection works the same in Blazor as it does in Xamarin as it does in ASP.NET Core. What you can do is you can put these helpers for registering this into the API client as well. So for stuff like, if we close this, if we go into startup, this add HTTP client with the middleware, we'll remove this span here because I am not a big fan of it, right? We can go ahead, grab this. We can create a new file. Let's call it API client register.cs. This is going to be a static class where we're gonna use iPublic iService collection. We will need to get Microsoft Extensions Dependency Injection Abstractions package. So add API client. Obviously, if you have some sort of a name for your API client, give it appropriate names. We will say this iService collection services, right? And then we're gonna return services on the end here. We will need a few more packages to basically be able to register our custom HTTP client. So if we go into the startup, so wherever we did the startup, close everything. So the startup here, just F12 on the HTTP client. We can take a look at the assembly. So Microsoft, what's it called? Extensions HTTP. Let's copy the name. Let's go into manage Nugget packages, browse, look for this package, grab it. Once this is here, what we should be able to do is add the HTTP client. Obviously, we will have the middleware. This method also needs to be static. We can just go ahead and do the registration of the middleware as well. Okay, so I'm gonna, for this, because the middleware is primarily going to be used by the custom HTTP client, I'm gonna remove this from here, and I'm gonna move the middleware appropriately for this custom client here. Okay, where it's gonna be consumed. So saving this, so moving forward from here, what I don't want to have is this custom HTTP client here. What I also don't want to do is surface the HTTP context. If you want, you will need to grab the appropriate namespaces and stuff like that. I'm gonna remove it from here for now, because I don't think this is the point of this. This is more about pushing down, just the idea of being able to grab packages as you need them. Okay, still the same middleware applies kind of thing. The primary thing is that this client is particularly going to get the objects that are defined in your API. Okay, so here we basically add the registration. What we want to do now is, let's go into startup. Let's actually rename this from custom HTTP client to API client. Okay, let's rename the files as well. API client, make sure API client register is renamed as well. It is. Let's save everything, go into startup. I apologize if jumping around the files is a little bit confusing. Hopefully you get the gist. Services, we go ahead and add API client, and to be able to add it, we need a dependency. So add project reference to API/client or .client. We are just going to grab the namespace. Okay. So one thing here is, for example, where we do the API client's registration, where we have this action here. We can name it API client or whatever. You don't have to name it at all, as I've said before, because you're just going to be injecting the type. This function here, so if you need to push down the function as well, just take a look at the signature, action HTTP client, and just pass it as part of this middleware here. So let's go ahead and say the client here, client configuration, import HTTP client, and then we can basically pass the client configuration in here, grab this client, and then based on who is the consumer of the client, they can specify their own configuration, what server are they point to, what basically if the load balancer IP changes, whatever happens, just pointed to a different place. We then go to ASP.NET Core Startup, and we just, again, we preserve the pattern and we supply the configuration in the same way that it is done for all the other ones. So it seems, yeah, the error here is just different package versions. So let's go ahead and bump the abstraction ones down to 0 here. Make sure it stops crying. Maybe the HTTP context one will have the same problem. It doesn't seem like it. Go ahead, format this. So we add an API client. Again, the configuration is more or less the same, where the API client is actually now living in a separate project. And what is the problem here? I think this should have been resolved now. So this is, I think this is just Visual Studio lagging here, so it'll catch up in a bit. Or maybe if we encounter an error, it's always something we can solve. But yeah, the gist is that you have a container and you just call a specific function to add a very common API. So all you do now is, let's go ahead into our home controller. Let's go ahead and call this shared, because it's a shared client. It's a client that can be shared between this consumer and any other consumer, right? So API client, using client, get home. Again, it's kind of the same definition, except here we return a task of home. So because we inherit from the entity project in our API client, and basically we get the reference to home. So this is something we should be able to reference, add reference to entities. Yep. Okay. So that's that. Hopefully it still works. Let's check the console. It looks like everything's broken because of the packages and stuff like that, and unable to rebuild. Again, as I said, might need to restart it because .NET Watch Run doesn't support well if packages are changing, etc. Let's go ahead and stop all this. We will do a rebuild here, and let's go through these errors one by one. So first error is in the middleware. Microsoft ASP.NET Core HTTP package is not working. Okay, that's fine. Build again, maybe that's gonna be resolved. Okay, so home, yeah, we want to change this to name. A bunch of errors as I was speeding through this. Yep, home does not contain. Yep, it does not. It's a name now. I rebuild this again. First one is, what does the error say? Microsoft dependency. Both of these are downgrading, so the I guess the initial error that caused me to put a 0 there on the end is kind of was a trick. It was an illusion. Okay, all is running, or all is building. Let's go ahead and call .NET Watch Run on both of these. Hopefully they will start, and we can do a test on the shared client and make sure that it's working. Right, so here we are. Let's get Google Chrome up. Let's grab our shared instance. Okay, and here you can see our home, right? So yeah, primary things to make sure that you're basically following with the HTTP client as kind of an overview. Let's go to the startup and kind of go over our options. What you can do is you can add an HTTP client without a configuration. This is just if it's a one-time thing. You just need a quick HTTP client. You don't need to create any abstractions. You just one call, right? Simple scenarios, no name, no nothing. Just add a HTTP client, get your HTTP client factory, service your HTTP client. If you need a little bit of setup, if you're going to be using this HTTP client in more than one places, and you just need a little bit of consistency, the configuration that you supply here is going to be triggered. It's going to be triggered every time you're going to call create client on the HttpClient If you need different configurations for different clients, so if you're going to be calling, I don't know, like GitHub on the Facebook API, you might want to give them different names. But at that point, if you're going to be needing like static typing support and binding, you probably want to go towards the typed client, where again you can define specific methods that you want to return. And again, if you are going into the sort of a microservices architecture where your API is being consumed by more than one consumer, right? you might want to create a separate project, and from here on out, right, you can use the system.net http.json package to basically help you do handle the serialization. And again, you can put all the middleware stuff in here, and as well as the registration with a container and the API that you create here, because you inject the statically typed API. You get basically the static typing and the actual methods that you've set up here, right? But that's the gist. Hopefully you can see the difference between kind of like the simple, the middle simple, and the hard part. So your simple one is just get your HTTP client, do a quick call. The middle one is you have kind of like a base configuration, because you might need to be doing multiple different calls, but still to the same endpoint. And you might need this kind of simplish configuration for different endpoints. Then you can basically set up different clients. And then you get into the typed client, which is a little bit more work and a little bit more maintainability. But again, all that logic is segregated into that one client, and you can just inject that one type straight away without using the IHttpFactory, okay? And then the most complicated, because it's sort of living in its other project and it has to synchronize with all consumers, is when you basically abstract the HTTP client into its own project, but you can still basically integrated with the registration of the .NET container, which is the iService collection. Okay, well, yeah, this is essentially it. Don't forget about the system.net HttpJSON package. I think it's going to be the preferred way moving forward. If you enjoyed this video, leave a like. Don't forget to subscribe for more. If you have any questions, as always, leave them in the comment section. I also stream on Sundays and Wednesdays, so if you would like to be notified of that, join my Discord server. You can also ask for help there if you don't like the YouTube comment section. But yeah, hopefully I'll see you in my other episodes. Bye-bye.